model the surface and calculate the flow. It will give you lift and moment coefficient by direct surface pressure integration, and drag is found from the moment thickness at the end of the wake. A viscous analysis can be performed by coupling the inviscid solution with boundary layer solver using a surface transmission model. A more detailed description of it would be in particular available in the manual itself, which you can find it in the folder that you installed it. So there's two processes in doing this. One is you want to complete an angle of attack sweep in Xfoil analysis using inviscid and viscous analysis. And finally, you want to use the knowledge of how to run for a known airfoil to design an airfoil of your own that is best believed to be suited for a remotely operated heavy lift competition aircraft. So that is your design objective. You're kind of like modifying your knockoff 4-digit airfoil till you get an airfoil with the performance metrics that satisfies this particular design. All right. I would suggest you to screenshot this slide. That's all the commands that you need to run Xfoil. Oh, all right. Okay. If everyone is good with this, let's start the actual experiment. So in the folder that you have airfoil installed, click on the Xfoil. So it will open a command window for you. So first, let's try it in Visit. So first you go with knockoff, which is the type of your airfoil. Then you type in the 4-digit, which is 0015. Upper, which tells you that you want to perform some operation, PACC, and then you would tell it the file name to save your data in. In this case, let's call it lab 5.1, which is the first part, .txt. So as you can see in the same folder, it would create that file for you. After you created the file, press enter. Finally, ASEQ. And it tells you what is the first value for alpha value, which is the angle of attack interest. So you start with 0, and your last value would be 20. So you want it to go from 0 to 20. And I'm choosing the increments of 1 degree. And it would spit the result out for me right away. So for each angle of attack, it tells me what is CL, CM for that particular alpha. Now, any questions on the first part? It's really straightforward. It's like nothing like CFD, which was time taking and took a lot to do the design.
Oh yeah, after making the file, it's when I tried putting like the angle of attack angle, I think it said command not recognized.
So
Not
after
sure if
you
I'm
made the file, you have to press enter first, and then. Okay, so let's go through this one more time.
thanks.
All right, so follow up this time. You go with Naka. Actually, let me delete the file that's already created, otherwise it would give me an error. Okay, so open Xfoil. Okay, open Xfoil. First command is Naka. Then you have 0015. Then OPER, which tells it to go to operation. PACC. Then the lab, it's lab 5, part 1.txt. Press enter, and then press another enter. Okay. And then you have ASEQ. Angle of attack starts with 0, go for 20 in increment of 1. And you have your solution. And if you look at the file here, it would spit out the information you need. You can take a screenshot of it, or you can take a look at the file and extract information from it, from the text file. All right, now let's try the viscous method. So for the viscous method, you start the same, you go for knockoff, 0015, then you have upper for the operation, and then you specify that you're going to go with the viscous flow, so you enter VISC. It asks for a Reynolds number, and try starting with 250K, so 250 and then another 3 zeros. Then you go for PACC. It asks you what file name you want to have it saved. So lab 5 this time, I'm going part 2 .txt. Then press another enter because you don't want to pull her down. Finally, ASEQ, press enter. The first alpha is 0. The last one is again 20, and you want to go an increment of 1. And it will give you the data you're asking for. So if you see that there are some anomalies in between, you can try a smaller increment. You can go with 0.5 and see how is that going. And it would give you the information that you need. And if you go to look at the file, again, they're sped out in the file, which you can either export it to Excel or you can export it to MATLAB. Right? Any questions? So it asks you to calculate a Reynolds number that's corresponding to your previous tests. So 250,000 is very close to it, but it's not exactly the Reynolds number corresponding to the experiments that you guys have done. So you have to look back at the conditions like room temperature and pressure that was part of your experiments for lab 1 and 2 and 3, and calculate a more accurate Reynolds number. The 250K is just something close to it that would work and give you guys some result that they can show you during the lab. But the real Reynolds number, to kind of make sure that your results from this test are corresponding with your experiment in previous ones, you have to calculate that on your own. All right, any other questions? All right, if you don't have any more questions, I don't have any more to present or nothing else to present, and you may feel free to leave. Frankly, I don't know what the top and bottom XCR is. I can try and ask Dr. Bamsfield and let you know. But for this particular lab, you only need the CL, CD, and CM.